Okay, so yesterday we talked about IP addressing and types of IPv4 addresses.
Yeah.
Multiple classes were there, and
Yeah.
each class
And
have a
the
fixed range. Okay.
different type of networks.
Right. And identifying which network, whether multiple IPs are part of a network or not.
Yeah.
So next is our subnetting. So what is subnetting? What do you know about subnetting?
Subnetting is when you don't have many IP addresses available, and then you divide it further in subnet.
Right. So when we have a big network and we want to divide it into smaller subnetworks,
Yeah.
so that we can you can say control your traffic. You don't need to use multiple networks there. You can work with the
Yeah.
same network, and in case in future you want to integrate it, combine it again, that is also a little bit easy. Okay. So
And when we doing subnetting, can you also like give me a example as well, like where we normally do subnetting, like in if we want to do subnetting for like a small number of clients,
mhm.
just to
Depending on the like what how many clients or how many IP addresses you want in a network, in the new subnetwork, we can do the subnetting. Like first of all, let's say I want to create a team, and in that team I want that 200 systems should be connected with each other and they can communicate with each other. So which class would be better for this solution, for this situation? Class A, B, or C?
um, class A.
No, class A will not be suitable because in class A we have 1 crore 67 lakh something IP addresses in a single network. But in our case, we only need 200, and it may
Yeah,
increase,
so
but
I
it
think
will not be going above
yeah, so it's
250.
a C.
Right. So let's say I took this IP address of class C 0.0/24, which total number of IP addresses is 256, and usable IP addresses are
254.
154.
Yep, yep, yep.
So if I wanted to do this, we could have used this class C network and created the network. But now what I want to do, I want to divide that network, divide the team into two parts, or
Yeah.
let's say four parts. And I want that in each department, there should be at least 50 devices. It could be a little bit more than 50, but not less than 50.
Yeah.
So I want 50 devices here, 50 in the next one, 50 here, and 50 here. So that they will only be able to communicate in their team only. If they want to go outside of their subnetwork and try to communicate with the next one, then a router is needed or some extra configuration is needed. By default, they should not be able to communicate with the other
Yeah.
departments. Okay. So before we had 256 IP addresses. If I used the same, like I used four networks here, 192.168.0.0, then next, let's say 192.168 1.0, third one 2.0, and 3.0. We could have done it like this, but what's the issue with that? First of all, we are wasting a lot of IPs, because if we see after out of 254, we will only be using 250 in a single network. So we are wasting around 200 in each. So around 800 of IP addresses will not be used. And let's say in future, if I want to again combine them, then I need to revise the IP addressing on all the systems again. So your work will be a little bit extra at that time. So other solution was that we can do the subnetting of a network that is already available to us. So instead of using 4 different networks, we can only use a single network. So for doing the subnetting, multiple steps are there. First of all, you need to know how many devices you want in a single network. So you can say your required host value you must know. So in our case, required host is 50.
15.
Okay. And before that, can you tell me how many network bits are there and how many host bits are there in class C default?
16.
24 network bits because we have CIDR /24.
Okay, you're asking in this one. Okay, sorry.
So 24 network bits and the remaining 8 bits are of host. That's the default value for class C. Okay.
Yeah.
Then next, after you know that the required host is 50, the second value that you need to calculate is converted, because before there were 8 host bits in the network in your IP address, but when you do the subnetting, the number of network bits and the host bit will change. And there is a formula for calculating this value, that is 2 raised to the power x, or instead of x, let's use h, minus 2. This should be greater than equal to required host. So this is a converted host bit. And if you want to calculate the values, you can use the formula, or you can just create a table. Like if you are doing the subnetting for class C, then you need to create the table up to 2 raised to the power 7. If you are planning to do the subnetting of class B, you need to create the table up to 2 power 15. If you are planning to do subnetting of class A, in that case 2 power 23. 12, 11, 9.
Sorry, I didn't get this part. Why it's different for every network class?
Because in class,
We only discussed till 2 into raised to power 7.
like in class C, how many host bits are there? Class C, we only have 8 host bits.
Yeah.
If we start from 0 and go up to 7, those 8 host bits will be covered. So that's why we only need to calculate up to 2 raised to the power 7.
Okay.
In case of class B, the host bits are 16. So that's why we need to go up to 2 raised to the power 50. Okay. If you want to calculate, if you want to write this table, that's better. If you don't, you can directly calculate with the formula. Okay.
Yeah.
So why is it better to write the table? I'll show you here. Let's first create it. So starting from 1, just double the number, 2, 4, 8, 32, 128, 256, and 22512, 1024, 4044, 80, 80 plus 1696, 4096, 8, 1, 90, 90, 8, 180, 180, 190, 192. Then double 8192. So that will be 16, 100, 100, 200, 380, 384. Last one would be 16, 1632, 33, 600, 700, 768. Okay. So let's verify the last two values. I'm not exactly sure about that. So 2 raised to the power of 15. Yes, 32768 and 2 raised to the power 14. 60. Okay. So these are the values. If we put it in the power of 2, we will get this result. Now, how will you calculate the value of h? Just check these values, and in the resultant of these values, check which value is greater than your required host and nearest to your required host.
64.
64. So just take the bit number, that is 6. So here we directly got the value of h, that will be 6. Okay.
Yeah.
So if you create the table, then you can directly check the values. Otherwise, you need to solve it. Like you need to use the hit and trial method. First put the values like 2 raised to the power 5. Whatever result you are getting, minus 2 from that, and that number should be greater than equal to required host. Okay. So starting 2 values we got. Then the next one is converted network bit, will be n, and there is a formula for this too. Host bit of whichever class you are doing the subnetting of minus converted host bit. So what we get, default host bits are 8 minus converted host bits are 6. So the value of n will be then next value that we need to calculate here is total network bits, and we also have a formula, simple formula for that, that is default network bits plus converted network bits. So in class C, default network bit is 24 and the converted network bit is 2. So we'll get the resultant value, that is 26.
Sorry, actually I missed yesterday. So after this, I mean, can you just do one more? Give me just one more. You said now the default values are these default values 8 and 24. So I didn't get that yesterday as well about the default values of all the networks.
Okay. Like let me that. Okay, here it is. Or we can do it like this, like today either you go through this recording, the yesterday's recording, and we can move on with the subnetting part, because for subnetting you need to be clear about IP addressing. Only then you'll be able to understand the subnetting part better.
Okay.
So either we do the session tomorrow so that you'll be able to grab more content, but for that
Yeah,
you
I mean, I'm not. I mean, yeah, I'm not rushing. I mean, I can. I have time. We
mm,
have a lot of time. I can cover that. But I need to understand these things. Okay, what we. So that's the only way I can grab more in the next session. Otherwise,
yeah,
you keep
because
missing.
in this if you even like keep a single backlog only, even then you will be able to not be able to understand the next one, because mainly they are interlinked, and for that you need to be clear about the previous one. Okay, let me explain it for now. If you get it, then we'll continue with subnetting. Otherwise, check it
Yeah.
today and we'll start the next one tomorrow.
Yeah.
So like we have three classes, class A, B, and C. And it is predefined that in class A, there will be one block of network and the
So I
remaining
have
three will
to.
be of,
So do I have to memorize the that there will always be a one network block and three host block in class A?
yes, for at least class A, B, and C, you need to remember these.
Okay. So there will always be a one network and three host block in class A.
Right.
Hmm.
Okay. If they are different, like we talked about here yesterday, like the range was of class A, but the network block were different. So that was not our classful IP addressing, that was
It was classless, I would
classless.
say.
Okay. So that was classless IP addressing.
And how
So
we determine that it's classless, that's what I didn't get yesterday as well. Just
for
looking at the IP address.
for that you need to remember these values. Like if you just remember only these two, it will work. Because if the range is similar, like range is of class A, and it also have a single network block, that means it is definitely a class A IP address. But if the range is of class A, but it is having more than one network blocks, that means it is a classless IP address.
So the example that is below the 10.00./8, can you explain here how we can determine that it's a network, that is a one network and then there's three host blocks?
For that, like let me example. Let me take a different example. Okay. One and two. And let 231 2.0 slash 0.001 172.31 1.1. And I'm connecting these two devices. So for us to check whether they'll be able to communicate or not, first of all, check their last CIDR value, that is this one. CIDR is 16. And we know from here, like if the CIDR value is 16, that means that IP address have 16 network bits, and 16 network bits will only be in class B because two network blocks will be there, each having 8 bits.
Okay. Yep. That's how we determine it. Just looking at the slash value.
Right. Just by looking at the slash value.
So the slash value will always be there.
Hmm.
So the slash value will always be there. I mean, that's the only way to check how many network blocks are there and how many hosts are there.
No, not always the slash value will be there. In some cases, they might provide you the value like this. Instead of slash 16, they might give you the value like this, 255 25500. So in that case, you also need to remember the subnet mask, or you need to remember how to convert this subnet mask into binary by using this block formula.
Yep.
Okay.
Yep. Understood.
So after that, once you have identified how many network blocks are there, then you can match whether both the IP addresses and network blocks are similar or not. If the network blocks are similar, that means they are of same network and they can communicate.
Yep.
And just like let's say instead of this example, if we had like instead of slash 16, let's say slash 24 is there. Now tell me whether they can communicate.
So the network blocks are same, so they can communicate.
Check again. How many network blocks are there this time? Or how many network bits are there?
Is it
Just check the last CIDR value.
20? Yeah, so that's 24.
Right.
So there's a two network blocks and two host blocks.
No. We have 24. That means 3 network blocks, because if we have 24, that means the network bits are 24 bits. The CIDR value is nothing but the number of network bits with a slash. So 24 is the CIDR. So you need to write 24 times 1.
20, yeah. So two network. Yeah, it's a class.
3 network blocks. Network blocks will always be 1 in the subnet mask. Host block will always be 0 in the subnet mask. Or you can say the network bits will always be 1 in the subnet mask and the host bit will be 0. So if we got this value and if we want to convert this value, so in all the places 1 is there. So we need to add all those values: 128, 64, 32, 16, 8, 4, 2, and 1. And if we add them, we'll get 255, 255, 255, 0. And via this, we can tell 3 times 255 is there. That means 3 network blocks are there. Last one block is of host in both the cases.
So yeah, that's what I didn't get. I got that there's a three network blocks, but there's a zero host block. I didn't get that part. There's only 24. The value is only 24.
24,
So
it
it's
is telling
only
the CIDR value. It is telling you that there are 24 network bits in the network, in the IP address. But IPv4 address is an address of 32-bit. So the remaining 8 bits will be of host. In that, the values can change.
okay.
Okay. The CIDR is nothing but telling you the number of network bits. How many network bits will be there?
And then we can divide depending on the which IP address we're using. If we're using IPv4, IPv6.
Yeah, we are only talking about IPv4 for now. IPv6, we haven't got that part. In IPv6, the IP will be a lot longer than this. Just hold on a minute. Hello? Okay, yeah, sorry about that.
Yeah, that's okay.
Okay, yeah, where were we?
So you're saying that IP address IPv4 has a 32-bit, and so the value is only 24. So the remaining are the host bits, which is 0.
The host bits will be 8.
8.
Like out of 32 bits, it is telling us that the starting 24 bits are of network. So the remaining 8 bits will be of host. And after subnetting, you will get some values like instead of 24, you can get 20, or you may get 25, 26, 27, 28. It could be anything depending on the number of hosts. According to the number of hosts you have done the subnetting. So let's say if I have /20 here, what does it mean? It means the starting 20 bits are of network. The remaining, how many are remaining? The remaining 12 bits.
These 12 bits are host.
Right. Okay, so that will be our classless IP addressing, because in that we are not following a particular class. If we were following a class, in that case, the range and the not network blocks would have been similar. That would have been our classful IP addressing.
Yep, yep, yep.
Okay. So in this case, whether we'll be able to communicate or not. So for this, whether the IP can communicate or not, you need to check two values. First is the how many network blocks are there. That's the first point. And the second point is whether the network blocks are same or not for both IPs. The network blocks for both IP are similar or not. If they are not similar, they will not be able to communicate. If they are similar, that means they are of same network and they can communicate easily.
So in this case, they are similar and it's the same number of blocks, so they can communicate.
Nope, they are not similar. Check again. The network blocks should be similar. How many network blocks we got here? According to this /24, we got 3 network blocks.
3 network blocks and
If we see
house.
the first block for both 172 is similar. The next is 31, it is also similar, but this one here we have 0 and here we have 1. So they are not similar. They will not be able to communicate. Like, let me show you. Like we have the Cisco packet tracer on which we will be doing the practicals. Okay, so here in end devices in the left hand side corner, you can select PC and 1 and 2. Then here we can select the cables, and for now I'm using automatic and just click on that. So they're connected. Next, I want to assign IP addresses on both of these. And I'll be using these IP address 172.31.0.1, 172.31.0.1, this time /16, 172.31.1.1, and again /16. Let's assign these IP addresses in the system. While you're assigning the IP addresses on your system, you will go to IP configuration, IP addresses, provide the IP first. In the subnet mask column, you need to provide the subnet mask. So by default, it checks the class and takes the default subnet mask for that class. So for class B, the default subnet mask is 255.255.0.0. And right now we are taking the IP address of class B, so we don't have to change anything. Save this. Just close this. It will be saved. Same thing do here. Go to desktop, IP configuration 172.31.1.1, and here it also got the default subnet mask, and close it. So IP has been assigned on both of these. Okay. If you see here in the IP address column, what it is showing, 172.31.0.1/16. So for checking the connectivity, again go to your PC, go to command prompt and run the command.
IP.
If you want to check the IP, we can use ipconfig. If you want to check connectivity, use ping 172.31.1.1. Enter. We are getting the response from there. That means we are able to connect to that machine for now, because the IP addresses are of same network. But if I used 24/24 instead of /16, let's also change it in the systems too. Go to IP configuration and put one more 255. So 3 times 255, then 0. And this one too. Times 255 and then 0. So if you check the IP now, in the IP address column, what are we getting? /24. And if you try to run the same command, I'm not changing anything, I'm using the same command again. So we are getting request timed out, because according to PC0, PC1 have an IP address that is not known to him. We cannot communicate with that PC until we use a router and do the routing, provide the gateway and everything. Okay, because there are different networks.
Why would they connect? Because the network blocks are different. Here it's
Right.
showing 0 and the other one is showing 1.
Yep. That's what I'm telling, like how you can identify them. You can check the network blocks and then you will need to check whether the network blocks are similar or not.
But why it works with the 16/16? It works with /16.
Yeah, it
When
will
you
work
can,
with /16. Why is that? Because if we write /16 here in the same IP address, and here too. So if it is /16, that means how many network bits are there? 16
8.
network bits.
Oh, sorry,
No, no.
16 networks. Yeah, sorry, 16. Yep, yep.
Write 1 16 times. So 4,
Yep.
5, 6, 7, 8. Put a dot. 1, 2, 3, 4, 5, 6, 7, 8.
Okay.
Another dot, and the remaining bits will be of 0. 2, 6, 7, 4, 4, 8. Same thing will be true on the next IP address here. Here we also have 16, so that means the the subnet mask in binary format will be this. And if subnet mask is this, in which all the ones are there in the block, that means if we convert it to decimal, we'll get this value for that one as well as this one. And the next thing is that you need to remember that if there is 255 in a block in subnet mask, that block is of network. So we have 2 times 255, that means there are 2 network blocks and 2 host block. Here and here. And if we check the starting 2 bits, 2 blocks here, because only 2 are network blocks, and network blocks should be similar if they are a part of same network. So if we check the starting 2 blocks here, 172, here it is also 172. Next is 31, here it is also 31. So just by checking these two values, we got that they are of same network and they can communicate.
Yeah,
As for
so
the
the same case goes for /24 as well.
yes,
So
same case goes
they
for 24.
so they can connect as well, right? So they can communicate as well.
No, why? No, they cannot. Here they like in /16. Why they are able to communicate? Because 2 network blocks were there, and those 2 blocks are similar. Correct?
Oh, okay. Yep. Got it. So the third one, because in 24 we will have 3 network blocks, but the third one
Right.
in the IP address is not similar, so that's why they won't be able to connect.
Correct. So
Okay,
they will
got
be
it.
of different.
Got it.
Okay. So let me save this one. And yeah, so back to our subnetting part here. We first checked like how many hosts we required in a single subnetwork, the new network that we will be creating. Then converted network bits, like converted host bit. Default host bits were 8 in class C. So for calculating that value, we have a formula 2 raised to the power h minus 2, and the value should be greater than required host. Okay. So either you can calculate it by using the formula hit and trial method, or you can directly create this table, which is on the right hand side, and then
If
use
we
the
don't want
reference.
to use the table, then how are we going to use the formula? We don't want to
You
create the
will,
long table.
yeah, in that case, the process will be long. Like you need to make a guess first of all. Like if you put something into power, you need 50 values. So you need to put like, let's start with 4. So 2 raised to the power 4, that's 16. It is way less than 50, so it's not true. So 2 raised to the power 5, it's 32, still is smaller. Then go to 2 raised to the power 6. We got 64, minus 2 from that. We got 62. That is greater than our required host. So that means the value of h is 6. Okay. So in hit and run method, you need to make a guess, like it could be some closer to this value, and then solve it one by one. Then the third one is converted network bits. And for that we have formula like default host bit minus the converted host bit. So we'll get the network bits that will be converted from for in the new network. So we got value 2. And in the total network bits, you just need to add your default and converted network bits. You'll get the value 26. After that, fifth value, that is the CIDR. There is nothing but the total number of network bits with a slash. Total network bits we got from the fourth point, that was 26. So CIDR will be slash 26. Okay. Then sixth is subnet mask. Subnet mask in binary and in decimal. Case of binary, from the above value, from the CIDR value, check what is the CIDR value, slash 26. So just write 1 26 times. 1 2 3 4 5 6 7 8 dot 9 10 11 12 13 14 15 16 dot 17 18 19 20 1 2 3 4 24 and then 25 26, and the remaining will be a, and now convert this value and tell me. Yes.
Sorry, can you tell me again the one that you converted in binary?
Like till CIDR we got how we got. Okay. So in case of subnet mask, just see the number in CIDR value and write 120 that many times. If the CIDR value you got is slash 18, so you need to write 118 times here, and the remaining bits will be of 0. Total should go up to 32. So if we see 8 plus 8 16 plus 8 24 25 26 27 8 9 10 31 32. Okay. And once we got the value in binary, we just need to convert it to decimal. So convert it and tell me the value, like what we'll get in decimal if we convert this subnet mask, which is available in binary format.
I need to write it down first. Give me.
Hmm.
I need to write it down. I need to make a chart.
Yeah, sure.
So three is 255, 255,
Mhm.
and the other one is 192,
Last one will be
192.
192. So this here, this subnet mask will be the subnet mask for your new subnetworks, which we will be creating here. Okay.
We
Then
got it.
okay. And then the next point is number of subnets. How many subnets we will be able to create here? If we did the subnetting according to the required host 50. For that we have a short formula that is 2 raised to the power n. N is our converted network bits, which is for now 2. We'll get the answer 2 raised to the power 2. That means 4 subnets will be there. And the last one is the block size, or you can say number of IP address in a single subnetwork. For that we have a formula 2 raised to the power h, and the value of h is 6. So we will get 64 IP addresses in a single subnetwork. So till here we got almost everything. The last thing that we need to calculate is the range. Okay, like 4 subnets will be created. We know that when we break it, we will get 4 different subnets. But we also need to calculate the network address and the broadcast address for those 4 subnets. Okay, so my IP is starting from 192.168.0.0. And let me write the range here. So 4 subnets are there. I'm writing them in different colors. First subnet will start from 192.168.0.0/26. Okay. The next IP of this network will be 192.168.0.1.
Yeah.
So one way is that you can first directly calculate the network address for all the IP addresses. And how do we calculate that part? So let me write it here first. Address, then first usable IP, last usable IP, need to calculate these 4 values for all the subnetworks that we will get here. Okay. So the first will start from 192.168.0.0. As for the second one, if you want to know where the second one will start from, so check the new subnet mask you got. Check the value in decimal. In which block the value is not reaching 255? The last block, right? It's the
last block.
Last block. So what you need to do is take the value from the block size, the 8 point, and add it in the IP address in the last block, in the block where the subnet mask is not reaching 255. So if I add 64 in 0, what will get? 64. 192.168.0.64. This here will be the network address for the second subnetwork. And for the third one, add 64 in the network address of the second network. 192.168.0.64 plus 64 will get 128/26, and the last one 192.168.0 dot add 64 in 128.
It's 192.
192. So now we got the network blocks of all the 4 subnetworks that are possible here, and the remaining things you can easily calculate. Like the first usable IP will be the just the next IP after network address. Then the last usable IP, leave it for now. First write the broadcast address. So the broadcast address for the first subnetwork will be 168.0.63. Why 63? Because 64 is being used by the second subnetwork. You can say the broadcast address for the first subnetwork will be an IP just before the network address of the second subnetwork.
But yesterday you told me that the first and the last one will be the broadcast. The last one will be the broadcast, and first one will be I don't know.
Absolutely, network address.
Network address, yeah.
Yeah, that was true when we were talking about classful IP addressing. Like if we used the whole network, in that case, that will definitely be true. But now we are doing subnetting. Now we are breaking that particular network into multiple parts.
That's
Like,
only in.
let me show you here. Like we saw these rooms yesterday, correct?
Yeah.
So let's say I'm taking this room number 30 from here. And let's enlarge it a little bit. And let's say we have 256 chairs in this room. Okay. Oh, and subnet. And one more. Okay. And let's say we have 2 entrances here, and I told the people who will be sitting here that the first chair and the last chair of this room needs to be empty. Nobody can use the first and the last one. Okay. So the remaining 254 chairs can be used. They can sit there, they can communicate with each other, they can do anything. But later on, what I did, I divided this whole room into multiple parts. Before there was only one room, and let's say each tier had a number starting from here 1 and ending at, let's say, 250 or 200, just for example. So starting from 1 and ending at 200. But when I created room, I created some walls here, and now I got 1, 2, 3, and 4. Okay.
Yeah.
So now we got 4 rooms, and let's say I want to give 2 entrances in each room. So whenever I give 2 entrances, each room will have a seat, or you can say 2 seats that will be blocked again. So before, when there was a single room, only one network address and one broadcast address was there. But now we have 4 rooms. Each room will have a network address, each room will have a broadcast address. That's why we are getting 4 network addresses, 4 broadcast addresses, because we divided that room into multiple parts. Okay.
Understood. Yeah.
So that's why here we got 4 subnetworks. From 7th point we got it, like 4 subnets will be there. So this is their range. So the first subnetwork will start from 192.68.0.0 and it will end at 63. The second one will start from 192.68.0.64. The first usable IP will be just next IP to that, that is 65. The broadcast address will be 0 dot
64.
no, 64 is the network address of this network. What will be the last IPF address of this network?
The last one will be 60. 63.
No, it cannot go backwards. 63 was already assigned to the first network block, first subnet. This is the second subnet, then the third subnet, then we have the fourth one. Okay. Like here, like let me show you. Let's say this was seat number 1. Then this was seat number 6. Then 6, 10, 9, 10, 11, 12, 13. This one is 14. This one is 18, 19, 2, and 30. Okay. When we didn't create these smaller rooms, only seat number 1 and seat number 36 was not to be used. But when we created multiple rooms, the first seat and the last seat of the room cannot be used. So if you see, seat number 1 and seat number 14 are used, or you can say are occupied. In this one, seat number 6 and 18, and this one 19 and 32. So here I'm just naming them, numbering them randomly. But in case of IP addresses, it will go in a sequence. It will start from 0 and the maximum it can go is 255.
Yeah.
So,
So the last one is 255.
Last one of which subnetwork? Just see here. You need to start from 1 or 0. Okay. You need to start from 0 and you need to go up to 255. And while you are going to 255, you need to create batches of 64. That in a single batch, only 64 digits should be there. To create those batches, start from 0.
64.
No, that will be 65 numbers because 0 is included there. So the first batch will be 0 to
0 to 63.
3. The next batch will start at
64.
where it can go.
128.
Count it. If you use 128, if you include that one here, it will be 65 numbers. Because
so
we
that's
need
120, 127.
Then the next one, where will it start?
So that's 190, 120, sorry, 128. Yep.
And can go up to
191.
And the last one will start at
192.
Can go up
and
to
that's 255.
255. That's what we need to do while we are creating the subnetworks. We got the block size, we got the number of IP addresses in a single subnetwork, that it should be 64, not more than that. So if we divide 256 into parts of 64, we'll get this range. So here it will be 126, the last usable IP, and the broadcast address will be 127. Just like that for the next one. The first usable IP will be 0.129. Broadcast will be 0.191. Just one IP before this 192. And last usable will be 168 0.190.
190.
And similarly, the last one 168 0.193.
193.
168 0.255. And the last usable IP will be
254.
So when you do the subnetting of this network according to the required host value 50, you will get these range. Okay. So subnetting is all about how much you fiddle with it, how much you practice it. Okay.
Yeah, I think I need to practice a lot. Yes.
Yeah, for the subnetting part, you need the practice because without practice, you will not be able to get this formulas and at which step what you need to do.
Yeah, I will do practice today.
Yeah, and I'm also giving you an assignment. 0/24. The required host value is 31. 168.45.0/20. The required host is, let's say, 20. And 26.0. Number of subnets that you need to create is 8. And also try to do the last one, that is 172.25.00/16, and the required host is much. Let's see. Okay. So try to calculate these 9 values for each IP address 1234. So that will be total. How much? 9 4s are 36. 36 points should be there, and it in the range one you need to write these 4 values. So try to do these.
So I need to. So I need to do only the range, those 4 values,
No.
network address.
Yeah, if you can directly calculate that one, or you can just put this one, because if we have the range, we can know all the rest. Like if we in the range we have /26, so we got the CIDR. With the CIDR, we can calculate the subnet mask. And while you are writing the range, we got the 8th point, that is the block size of each new subnet, and how many subnets will be there. So almost each and everything will be available if you only write.
So I need to get all those 8 values for each IP address.
Yep. I'll also tell you the shorter way to do the things, but not for today. Try to do it with a long way today, because you will be able to get how the subnetting is actually being done. And once you got the concept, then we have multiple ways to calculate the subnet quickly. Okay.
Okay.
So let me save it. Okay, and okay, for now it's enough. Let me save it. Okay. Okay, so see you tomorrow.
Yep, I'll see you tomorrow. The
Yeah.
same time.
Yes.
Maybe it's always 10-15 minutes late for me because I finish my work at 5 p.m.
Okay, okay.
Sometimes I
Like
finish it early.
so 1:15 here.
Yeah, 1:15 here, 1:15 India.
Okay, okay, sure.
All right, thank you so much.
Okay, welcome.
Bye. Good day.
Bye.